Arthur, can you find one more person? We need another person for this thing. They lost one.
So the beginning of June of 2002, the year before launch picnic, we are 51 weeks from launch. Last week, the team went out and had a good lunch time and played a little volleyball. The schedule is the big concern on this project. You know, I tell my people that in terms of my top 10 list of worries, the first 3 are schedule, schedule, and schedule, and there's nothing in 4th place. And that's just very, very tight for a mission of this kind of complexity. And we've been fighting that challenge basically since the beginning. So the pressure now is on getting the flight equipment together through the assembly, test, and launch operations phase in order to get ready to go to Florida in March of 2003.
They owe us whatever we lose by. Donate.
The schedule situation has forced us to expend money at a greater rate than we expected, so we've had to go back to NASA headquarters and ask for an infusions of funds. They've been extremely supportive of our requests, and we've gotten everything we've asked for. But in going through that process, you worry about, have I got the right plan? Do I really have it figured out? Are we on track? Can we stay on track? My job is to make sure that the rest of the team, it's a very high caliber, very motivated group of people, can get their job done. So my job is to get the stuff that gets in their way out of the way. Keep this well-oiled machine running.
I think since this is the 0 degree, it's probably worth doing.
So I've got your concurrence that it will count as a test if it doesn't have the air data boom data.
Are you questioning whether you're going to get air data boom data?
The pilot indicates that we have a very high probability in these gusty conditions that we will smash the air data boom.
Yeah, we'll go. We will count it.
Got that, we're going.
I'm really amazed at the amount of spinning that we're getting. Well, there's altitude at location. Look at it. Oh. Look at that. That is splendid. Awesome. Awesome. Oh, that's fantastic.
That's great. Well, here's the thing too. If let's say this one hits and it's a good test.
We quickly found out that we weren't testing them the way they should have been tested. I think in the back of your mind, you're always prepared for anything to happen, but this wasn't one of the places that we thought something would go wrong.
We went back in mid-June and had the very dramatic, complete structural failures.
All right.
We're ready. Looks good. Stabilize, count, and drop. 5, 4, 3, 2, 1.
It was slightly devastating.
Significant, severe chute damage. Well, the political spin on this is pretty easy. Because this chute did not have any of the reinforcements that we put in to stop just these very kinds of failures, these kinds of failures are not surprising. And that's why we chose to use this. You got to remember, these soft goods systems like parachutes or airbags, they are not readily amenable to analysis. The inflation of a parachute is actually a chaotic event. It's a nonlinear, dynamic event, highly driven by the initial conditions of the inflation. In that regard, I'm not surprised or disheartened at all by this. I need to get the right spin on this so that no one else chokes.
That was of a nature that just makes you're taken aback. It even takes a day or two to absorb the magnitude of what just happened. That was rough. First of all, you have to figure out why you have a failure. You have to figure out what your possible fixes are, and you don't have the schedule to investigate this in a more methodical manner that you would like.
So we have to change our thinking on most likely the loads. And it didn't look like there was several different types of failure there. I mean, at least to me.
To me, it looked like there was.
Yeah.
But again, I'm looking through a little camera screen.
Well, even, I mean, it just, you know.
Did you hear it afterwards?
Yeah.
It's coming to you, Dennis. This comes for you. It's coming to you.
The fact that the parachute exploded, not a good thing.
Well, yeah, I'd rather have it happen here than
Mars.
else. Yeah.
That's right. Unfortunately, strictly speaking, that chute that just exploded was the chute that we were planning on taking to Mars. Complete structural failures. Repeated, complete structural failures of the parachute. And that was extremely distressful. I mean, that is a sense of panic, like, oh my God, what are you going to do about this? The chute failed in the correct loads. That tells us that we have a parachute that's not up to the job we need it to do. Because we have packed as much parachute as we can into the volume that's available to us, our only recourse in making the parachute stronger is to change the configuration and reduce the band length. The way you make it stronger is you put maybe other webbing or reinforcements or thicker fabric. The net result is that you need more volume to pack that fabric in. We don't have any more volume. It's going to require people to be brave, especially managers to be brave, because the certainty that we have the job done is going to come very late, and that's going to make everybody nervous. Our next pass through this, if it doesn't come together, it's an all go home thing. It's an over.
About a month ago, we began assembly, test, and launch operations. When the first part of the flight units are, or in our case, engineering models, are beginning to be integrated in the assembly facility where the spacecraft goes together. That's a big deal because it indicates that you now have completed enough fabrication that you can begin the test phase and begin to understand what it is we really have designed and built. And where did we build it a certain way and it behaves in a way that's unexpected, and to fix those problems so that at the end of that test period, we know exactly what the article will do so we can send it to Mars with confidence. We are doing 2 shifts per day. We started that from the very beginning. We knew it would be a challenge, but I don't think we adequately assessed how difficult it would be. I think that's been the biggest surprise.
The trouble is, it's great on paper, but until you put it out there and test it, you really don't know what you have. So our electronics are failing at our vibration tests. Sometimes we find out it's a real problem. In other cases, we realize there's nothing wrong with it at all.
There's 2 camps of assembling and testing the rovers and the spacecraft as a whole. The assembly, test, and launch operations team is assembling the flight hardware, the stuff that's actually going to go to Mars. Our area, the integration and test area, has our own lab, which is a clean room and a sandbox where we have rovers that we test in the dirt. So we receive 1 set of electronics, the brains of the spacecraft. And we plug into each connector and make sure that each connector works, and we start slowly building up a spacecraft on a tabletop configuration where then the flight software team can come in and develop the software that they need to operate each of the devices. And then as part of the test team, we start doing higher level functional tests.
The other one would verify that we didn't have a short to chassis.
I like to think my job was kind of like working in the garage. It was a lot of hands-on, knowing how the vehicle operated or how the vehicle was put together. You're trying to balance all these different groups. People want to use the arm, people want to use the mast and image, people want to use both of those together. At the same time we're testing in our lab, they're putting the real pieces together. It was a lot. I mean, it was a lot of time. It was 3 shifts around the clock every weekend, and there was always somebody in the lab just because things weren't ready yet for us to start testing. And your job is just to make sure that everything works.
I look at my type, please.
Okay, there it is.
No motion at all. That thing was stable as a rock.
Move a little bit. That was,
Yeah, that thing just...
no stiffening on that at all.
Did you hear anything now?
Is there anything? How was it, Eric?
If you get a gust of wind, the system starts to oscillate, and when you fire retro rockets, you might impart an horizontal velocity. So you might touch down with a very gentle vertical velocity, but you might be going 30 meters per second horizontally. When we did statistical analysis of that problem for MER, it came out that the probability of failure was unacceptable. So we needed to come out now with a solution to that problem. Camera and you take two pictures, and then you can look at the displacement in the two pictures, how much you moved, and you divide it by the amount of time between the two images. You can figure out how much, what's your velocity. You know, the laws of physics, you know, were good to us. Hey, this is doable.
We are doing what is our most recent, and possibly our last actually, test, taking the Fido rover out to some mysterious field site, we do not know where. And it's a fantastic site. It's an absolutely wonderful landing site. It's got terrific geology, and best of all, there aren't any bushes. Because this rover doesn't like bushes. It's good with dirt, it's good with rocks, it's terrible with bushes, because it's designed for Mars, where there aren't any bushes. Or where at least it would be a real discovery if we found one.
We're going to come up with more than you can possibly execute on a drive saw. Okay? What will happen is if we get in there and we find out on the basis of UHF data that we can do remote sensing, but we can't do IDD, then I'll try to get the full set.
The point of this test is to train the science team in how to do field geology with a robot that is somewhere else, and using it to simulate the kind of science that we're going to do on the Martian surface with the MER rovers. I don't know where we are in terms of latitude and longitude and what state of the United States we're in, but that doesn't matter. What we do know now is we know where we are in some synthetic orbital images. We've got images taken from overhead that simulate the kind of data that we'll have for Mars.
The SOWG meeting will begin in here promptly at 8:15. So at 8:15, I want everybody in their seats, in this room, quiet, ready to go. Which rock we choose will be influenced not just by the geology, but also by where we're going to go after that.
That's not something that comes naturally to a field geologist. We got to stay real focused on the task at hand, which is doing the best job that we can for 10 days of really simulating the science that we're going to do on Mars.
And you have all the geology
here.
Yeah.
I know you guys love the PanCam. Excuse me, can I have your attention just for a moment? I know you guys love the PanCam panorama, but don't forget one thing you've really got to focus on is what the next solid's going to be. So be looking at the current location front hands cam so you know what's in your work bag. Okay?
Good. We have 1, 2, 3, 4. Probably want to get this thing here.
Hey folks! Anybody's got questions, issues on how to do naming of things? Roxana Wales here is our expert. Go to her for advice. Okay?